So think about painting a room in your house. Like if a month later the paint starts peeling or cracking, what's your very first instinct?
Oh, you blame the paint, absolutely.
Right. You think, I bought a bad batch or this brand is terrible. But honestly, 9 times out of 10, the paint is perfectly fine. The real issue is that the drywall underneath was dusty, or maybe the primer was still wet. The paint is just the final layer, so it's simply revealing a problem that started deep down in the foundation.
Yeah, the top layer always takes the fall. I mean, we see this in construction, we see it in baking, and we absolutely see it in crafting. We want the visible surface to be the problem because, well, it's the easiest thing to point a finger at.
Welcome to the Deep Dives, everyone. Today, we're taking a stack of your sources, specifically this incredibly comprehensive, highly practical guide from decoupagenapkins.com and we're extracting the most important nuggets of knowledge. We really want to help you build the perfect, completely predictable product stack for your next project.
Right, because we are looking at the art and the actual science of decoupage today.
Yes, specifically focusing on using inkjet prints, decorative rice papers, polyvine finishes, and creating beautiful coasters and seashells.
And our mission here is really to demystify some of the subtle craft issues that pop up for, anyone in this hobby. We're talking about things like slight bubbling on the surface, or maybe a finish that feels a little bit tacky weeks later, or even just a mild cloudiness.
Which can be super annoying, but as the guide points out, it's never a reason to panic.
Exactly. It's usually just a tiny mismatch in your materials.
Yeah.
And understanding the chemistry behind those materials gives you total control over the outcome.
So there's absolutely no need for alarmism here. We're just having a friendly chat about the mechanics behind a really fun, rewarding hobby, just so you know exactly what's happening on your craft table. So, okay, let's unpack this.
Let's start with the foundation of literally any decoupage project, which is the paper. The paper you start with dictates every single step that follows.
Right.
If you want the absolute easiest, most predictable route, you start with professionally pre-printed European decorative rice paper.
Because the chemistry of the ink is already set, right? Like it's locked in.
The ink is completely stable, yes. It's manufactured specifically for this purpose, usually using industrial printing methods where the pigments are totally locked into the paper fibers.
Oh, wow.
Because of that, no fixatives or paper sealants are needed whatsoever. You literally take the pre-printed decorative rice paper and it's ready to go straight onto your project without any prep work.
That is so convenient. But I mean, a lot of crafters want to use their own custom images, family photos, custom graphics, things they print at home. So if home printing is that accessible, why does the guide flag it as a potential issue?
Well, home printing introduces wildcards. Let's look at inkjet printers first. I mean, inkjet inks are beautiful, but they're very often water-soluble. They just sit right on the surface of the paper.
Okay, so if I print an image at home and then I brush a water-based adhesive or varnish directly over it.
The water in that adhesive physically re-wets the dried ink.
Oh.
Yeah. You might see the image become fuzzy, or you might experience a little bit of ink movement or color bleeding.
So the wet adhesive is basically just waking the ink back up.
That's a really good way to put it. Now, laser prints are generally more stable because they use toner, which is fused to the paper using heat. It behaves very differently than liquid ink.
Right, because it's essentially baked onto the page.
Exactly. But even then, laser prints aren't entirely risk-free. Depending on your specific printer, how hot the fuser gets, the paper-type toner can still react unpredictably. It might haze over or resist bonding when wet products are applied on top of it.
It's basically like trying to walk into a rainstorm wearing a watercolor painting. Unless you put a raincoat on that painting, the water is going to totally ruin the image. You have to build a barrier.
You do. And the source material points out something interesting. By the time you factor in the cost of the printer ink, the extra barrier sprays you need to buy, the test prints, and the potential failed attempts.
Home printing isn't always the money saver people expect it to be.
Right. Using pre-printed decorative rice paper is basically like using a high-quality, foolproof bakery mix where the science is already perfected. Home printing is like baking a cake from scratch with untested ingredients.
But if you are going to print at home, you have to protect that ink. How do crafters keep the ink from running the second a wet brush hits it?
They use fixatives and sealants. And honestly, this is where the most common misunderstandings in all of decoupage occur.
Really? Just on the sealing step?
Oh, absolutely. Let's establish a golden rule right now. Fixatives and sealants are only for home-printed images. If you're using professionally pre-printed decorative rice paper, skip this entirely.
Good to know.
But if you printed it at home, You need a fixative to create that raincoat over the ink before any water-based product touches it.
I imagine the type of fixative really matters, right? You can't just grab whatever clear spray is sitting in your garage.
Oh, please don't do that. That's exactly where things go sideways. You have to use a paper-appropriate, non-yellowing fixative or sealant. The guide specifically warns against using improvised sealants.
Like, what kind of improvised stuff are people using?
Things like engine sprays, random hardware store clear coats, or oil-based sprays that were just never formulated for fine craft or paper art.
What actually happens chemically when someone uses an automotive spray on a really delicate craft paper?
Well, those heavy industrial sprays contain harsh solvents. On a porous surface like paper, they just don't evaporate correctly.
Yikes.
Yeah, they might turn cloudy immediately, or they might lack UV stabilizers, so they yellow over time as they sit in the sunlight. Some of them never fully harden, staying slightly soft. Or they cure so slick that they resist the decoupage adhesive entirely, causing your top layers to just peel right off.
Which brings us right back to that paint and drywall metaphor we started with. When a crafter uses the wrong fixative and it yellows or gets cloudy underneath a water-based varnish, who usually gets the blame?
The varnish almost always gets blamed.
Yeah.
The crafter sees a cloudy coaster and thinks, wow, the varnish failed.
But the varnish is completely innocent.
Completely innocent. It's simply acting like a magnifying glass, revealing a failure in the fixative layer underneath. Water-based varnishes like Polyvine are professional quality finishes, but they aren't magic. They can't fix a yellowing spray sealant or unsealed bleeding ink hiding beneath them.
Wait, so if I finish a coaster and a few weeks later I see a slightly tacky finish or mild cloudiness, my first thought usually is, I bought a bad batch of varnish. How can I train myself to look at the layers underneath instead?
It starts with understanding your product stack, literally every single layer from the surface up to the top coat. If you see cloudiness, just trace your steps backward. Did you use a home-printed image?
Yeah.
Did you use a random clear coat from the hardware store to seal it? If the answer is yes, your stack failed at layer 2, not layer 4.
That makes a lot of sense. So once you've solved the ink volatility with a proper fixative, you still have to deal with the physical structure of the paper itself. I mean, the ink might be safe, but how the paper physically handles the adhesive changes everything.
Absolutely. The thickness of the paper dictates how well it blends into your project, and more importantly, what kind of adhesive you're forced to use. In the paper world, weight is measured in GSM, or grams per square meter.
Let's talk about napkins for a second. I feel like napkins are the unsung heroes of decoupage. People outside the hobby might think they're too delicate or flimsy, but reading this guide, they're presented incredibly positively.
Napkins are wonderful. They really are. They're beloved by decoupage crafters because of their extreme thinness.
Right, because you don't use the whole thing.
Exactly. When you use a napkin, you're peeling away the backing and only using the single top printed ply of a 3-ply napkin. That single ply is usually sitting around 16 to 18 grammism. It's gossamer thin.
Why is that extreme thinness such a massive advantage?
Because it's so thin, a napkin practically melts into the surface of your project. It absorbs the adhesive perfectly, bonding the fibers directly to the substrate.
So it doesn't look like a sticker.
Right. When it's finished, it doesn't look like a piece of paper pasted onto a shell or a coaster. It creates a stunning, soft, painted-on look. Do they require gentle handling? Yes. But that gentle handling is just part of the fun technique. It's definitely not a flaw.
It's a feature, not a bug. So if napkins are 16 to 18 grammism, where does European decorative rice paper fall?
European decorative rice paper is really the sweet spot. It sits in the 30 to 35 grism range, so it's slightly thicker than a napkin, which gives it a lot of structural strength and flexibility.
So it's a bit more forgiving.
Yes, it handles beautifully without tearing easily, but it's still thin enough to blend seamlessly into your surface without leaving a harsh, raised edge.
Contrast that with, say, standard copy paper from a home printer or heavy scrapbooking cardstock.
Standard copy paper is usually 75 to 80 grism. Cardstock can be 176 grism or much higher. Thicker papers have a lot of structural tension. They just don't want to conform to curved surfaces easily. When you glue them down, they leave a very noticeable physical edge.
Because they're basically fighting the curve of the object. Working with a napkin or thin rice paper is like draping a lightweight silk scarf. It perfectly contours to whatever is underneath it. But trying to decoupage cardstock is like trying to wrap a delicate seashell in a heavy winter coat.
That is a perfect analogy. And because those heavy papers are fighting to pop back up, you can't just use a thin, elegant lacquer to hold them down. You're forced to use a thick, heavy glue-style craft adhesive.
Oh, and switching to a heavy glue completely changes the entire chemical timeline of your project, right?
It absolutely does.
Which leads right into the critical difference between dry and cured. This next part completely changed how I look at project timelines.
It's perhaps the most critical scientific concept in the entire guide. Dry and cured are not synonyms. They represent two completely different chemical states in the world of finishes and adhesives.
So what's actually happening at a microscopic level when something is drying versus curing?
Well, dry just means dry to the touch. The water, or solvent, at the very top surface has evaporated enough that it doesn't feel sticky to your finger. But cured means the product has fully outgassed.
Outgassed, meaning it's releasing something invisible into the air.
Right. When an adhesive is wet, it's full of moisture and go solvents. As it dries, the surface skins over quickly. But beneath that dry skin, there's still trapped moisture.
Ah, I see.
Over the next few days or weeks, that moisture has to slowly work its way up through the matrix and escape into the air. That slow release is outgassing. Only when that process is 100% finished is the product fully cured and completely stable.
So even if a layer feels totally dry to my finger, internally it's still moving and breathing and releasing vapor.
Precisely. And this is where paper thickness and your choice of adhesive matters so much. If you use a thin napkin or thin European rice paper, you can use Polyvine finishes for your entire process, as both the adhesive and the top coat.
And Polyvine has a huge advantage there, right?
Polyvine's massive advantage in the craft world is its incredibly fast cure time. The chemistry allows it to fully cross-link and cure in 5 days or less when used correctly.
5 days to full, stable outgassing. That's fast.
Yes, but if you use thick copy paper or cardstock, you have to use a heavy glue-style adhesive to hold it down. Mod Podge is a famous example. Plaid, the manufacturer of Mod Podge, explicitly states on their label that it requires a full 28-day cure time.
28 days. That is almost a full month.
Yes, and many other glue-style adhesives require similar long windows, even if they don't print it clearly on the label. Now imagine a crafter who doesn't know the mechanical difference between dry and cured. They glue down their heavy paper. An hour later, it feels dry to the touch.
Right. They tap it, feels fine.
So they immediately grab their high-quality Polyvine varnish and paint a top coat over it. What happens?
The varnish seals the glue in.
Exactly. The varnish forms a hard, protective, waterproof shell over a layer of glue that is still trying to outgas for the next 27 days. The moisture from the glue has literally nowhere to go. It's completely trapped.
It hits that waterproof varnish barrier and just exerts upward pressure.
Right. And what does the crafter see? They see slight bubbling pushing up the surface, or the moisture chemically softens the varnish from underneath, so the finish remains slightly tacky. Or they see a mild, milky cloudiness developing under the clear coat. And once again,
the varnish is just the messenger, but it gets the blame.
They say, "This varnish ruined my project," when in reality, the varnish did exactly what it was engineered to do. It created a waterproof seal.
Mm-hmm.
The problem was that it sealed over a wet, unstable, uncured foundation.
If I'm working on a weekend craft project to give as a birthday gift, 28 days feels like an absolute lifetime. I can't leave a coaster sitting on my dining room table for a month. But if I just use the thin European rice paper and the Polyvine method, I can safely finish the whole thing in under a week.
Yes, you can. Tailoring your materials gives you that speed and peace of mind. Thin paper plus Polyvine equals a 5-day or less cure time. It gives you incredible predictability.
Okay, here's where it gets really interesting. Because once you've mastered paper weight and you respect the outgassing process, the final step is customizing the exact top coat you need for the specific physical object you're making.
Right, the object itself matters a lot.
You can't treat a coffee coaster the same way you treat a decorative seashell on a bookshelf.
You really can't. Let's look at coasters first, because they take a severe beating. Think about thermal shock. A coaster has to endure a boiling hot mug of coffee expanding the finish, followed by a freezing cold, sweating glass of iced tea sitting in a puddle of condensation.
Yeah, it deals with intense heat and standing water.
And a lot of coasters are made of slick, difficult materials too. Ceramic tile, glass, resin. They don't have any physical texture for the glue to grab onto.
They're totally non-porous.
So for a slick coaster surface, your product stack needs to be highly engineered. First, you use Polyvine Multi-Surface Lacquer as your pre-coat. This lacquer is chemically formulated to bite into slick, difficult surfaces and create a really strong bonding layer. You also use that same multi-surface lacquer to adhere your thin rice paper down.
But you don't use it as the final top coat on a coaster, right?
No. For the final top coat on a coaster, you switch to Polyvine heavy-duty varnish. That specific formulation provides the extreme heat resistance and water protection that a coaster essentially demands. And the guide offers a really great pro tip here. If you want maximum protection, build your initial coats using a satin finish.
Why satin specifically? Like, what does the finish matter for protection?
It's because of the solids content. Dead flat finishes contain a lot of flattening agents to kill the shine, which can subtly change the density of the film. Satin contains more of the raw protective resins.
Oh, that makes total sense.
So you build your armor with 2 coats of satin, and if you really love the look of a flat finish, you use dead flat just for your final visual top coat.
Build the armor with satin, finish the look with flat. That's such a great mechanical tip. Now, how does the stack change when we move from a heavy-duty coaster to a delicate seashell?
Well, seashells are purely decorative. They just sit on a shelf or in a bowl. Nobody's resting a hot coffee mug on a delicate oyster shell. Because they don't need intense heat protection, you can simplify the product stack entirely.
Oh, awesome.
Polyvine Multi-Surface Lacquer is the perfect all-in-one product here. You use it as the primer coat, you use it as the decoupage adhesive to stick the napkin down, and you use it as the final protective top coat.
The guide mentions that the gloss version of multi-surface lacquer is incredibly popular for shells.
It really is. Gloss highlights the natural colors of the shell and the paper design, making it look bright, polished, and finished without looking overly thick or plastic.
Which actually brings up a great comparison. A lot of people see seashell crafts online that are coated in thick 2-part resin. How does the look of a water-based Polyvine finish actually compare to a resin finish on a shell?
They yield 2 very distinct aesthetics. Resin gives a thick, poured glass, almost domed look. It's glossy and heavy, essentially encasing the shell so it looks like a piece of chunky jewelry.
Okay, and Polyvine?
Polyvine gives a much thinner, more traditional varnished finish. It actually beautifully follows the natural texture, the dips, and the ridges of the shell. If you want a decorated shell that still feels like an organic, natural object, Polyvine is absolutely the way to go.
And I imagine brushing on light coats of lacquer is a lot less intimidating than mixing and pouring chemical resin.
Much less intimidating. But there is one quick warning from the guide about mixing chemical systems that we definitely need to touch on.
Oh, right. Because some crafters love that vintage cracked paint look and use solvent-based crackle mediums.
Yes, and you have to be extremely careful there. You should never casually mix a water-based system like Polyvine with a solvent-based system like a heavy crackle medium, unless the manufacturer specifically directs you to.
What happens if you do mix them?
A solvent-based finish is not a rescue coat for an unstable layer underneath. If you're using a solvent crackle, you need to use the specific solvent top coat designed for that exact system. If you mix water-based and solvent-based products blindly, you're just asking for a chemical reaction.
Like what kind of reaction?
The layers might repel each other, permanently cloud up, or just stay sticky forever. Always make a test piece first on scrap material.
A test piece is honestly the cheapest insurance policy on your craft table, because customizing the varnish to the specific object completely changes the lifespan of the craft. I mean, treating a ceramic coaster like a decorative seashell is a literal recipe for a sticky coffee mug permanently glued to your living room table.
It all comes back to understanding the stack and respecting the chemistry of the materials.
Okay, let's do a quick recap of the golden rules of decoupage we've covered today. Number 1. Never blame the varnish for the fixative's crime. If it clouds or gets tacky, check your foundation, especially if you print it at home. Number 2. Embrace the delicate beauty of thin napkins and 30 drachm European rice paper. Their thinness is literally their superpower for getting that painted on look. Number 3. Respect the invisible chemical difference between dry to the touch and fully cured.
Crucial point, yeah.
Polyvine gives you a fast 5-day path, while glue-style adhesives demand a lot more patience to fully outgas. And finally, always make a test piece.
If you follow those 4 rules, you're going to eliminate almost all the frustration and wasted material in this hobby.
I want to leave you with a broader concept to ponder today. Think about that invisible outgassing process we discussed. The moisture and solvent slowly, quietly escaping from the layers on your craft table. Every time you layer these products, you're essentially conducting a slow-motion science experiment right there in your living room.
It's true.
It makes me wonder what other areas of our lives, our hobbies, or even our relationships are we secretly sabotaging just because we're rushing the clock between dry and cured? Sometimes things just need a little more time to breathe before we seal them up and call them finished.
That's a really great perspective. Patience is just as vital a tool as the brush or the paper.
So, what does this all mean for your next project? It means you can approach it with complete confidence, knowing exactly how your materials interact. Take your time, build your foundation right, and remember that a little patience makes for a perfect finish. Thanks for joining us on this deep dive, and happy crafting, everyone!